All right, problem 45 says an airplane flies at an altitude of 5 miles toward a point directly over an observer. As you see here in the figure, the speed of the plane is 600 miles per hour, and they want you to find the rate at which the angle of elevation, theta, is changing when the angle is 30 degrees, 60 degrees, and 75 degrees. So you have a picture drawn for you here already, and I can see whoever wrote in this textbook is recommending that we call the distance from the person to the point directly underneath where the airplane is. They're recommending we call it X, and I think that's fine. Anyway, so let's figure out what we want and what we have. Okay, it says rate at which the angle of elevation theta is changing. Okay, so we want d theta dt, and we want it at the moment when theta is 30 degrees. We want d theta dt at the moment when theta is 60 degrees, and we want d theta dt at the moment that theta is 75 degrees. So what is it we have? It says the airplane flies an altitude of 5 miles toward a point directly over an observer, blah, blah, blah. Here we go. The speed of the plane is 600 miles per hour. So that would be the change in that x value with respect to time. Since they said the plane is flying basically always at an altitude of 5 miles per hour. So with that said, x, the distance between the plane and, the horizontal distance between the plane and that person there, right, I don't know how to word that, x basically. I hope it makes sense. X is decreasing as the plane flies toward the observer. So I would say negative 600 there for that part. Next, let's find an equation that relates theta and x. We could use the 5. I'm going to go with, so 5 is opposite, and then x is adjacent. So I'm going tangent. So tangent of theta is opposite over adjacent. There we go. And now we're going to take ddt of both sides. And then for 5 over x, just so that I don't have any unnecessary quotient rule silliness, I'm going to make sure I write it as 5 times x to the negative 1. All right, derivative on the left side, derivative tangent is secant squared. Don't forget chain rule, since theta changes as time changes. On the right side, we're going to take the derivative. We'd end up with negative 5x to the negative 2. And then again, x changes as time changes. So it's a function of time as well. All right, I'm going to solve for d theta dt. I'm going to multiply both sides by cosine squared theta, since secant is 1 over cosine. And so I'd end up with negative 5 times cosine squared theta over x squared times dx dt. There we go. And remember, dx dt is a constant rate, so we can go ahead and substitute that in. Go. So d theta dt then would equal, so negative 5 times negative 600 is positive 3,000. There we go. And so now it's just a matter of finding d theta dt at these different angle values that they asked us about. So I'm going to go ahead and sketch the right triangle again here. Okay, so let's see if this is, let's look at d theta dt. D theta dt when theta is 60 degrees. So let's see, what would, so here's x, right? So the question is what would this be? This is always 5, and what would this be at the moment that this is 60, So I guess I drew that picture kind of sadly, I guess, now that I think about it. I think it's a concept picture, but still, it's more like this, right? So yeah, so 5, and then, what would this be down here? So you could, probably figure this out pretty well just by using 30, 60, 90 triangle stuff. Or you could, think of it this way, right? Like, what would cosine of theta be, right? So cosine of theta is, sorry, actually not cosine, I apologize, tangent of theta. Tangent of theta is opposite over adjacent, right? And then, if theta is 60 degrees, you'd be taking tangent of 60, right? And so just imagine, 60-degree dot in the unit circle. What's the sine? It's root 3 over 2 divided by the cosine. It's 1/2. Flip and multiply. You're going to get root 3. And so, right? And then solving for x, you could multiply x and divide by root 3. Sooner or later, you'd end up with that. You could always rationalize that denominator as well. So that would be your x value. And so here we've got x is 5 over square root of 3, and then what would the cosine of that angle be? Well, the angle is 60 degrees. So the cosine would be the x coordinate. And so that would be 1/2. So now like at this moment when theta is 60, what you can put in for the different pieces, right? So you'd have 3,000 times cosine is 1/2. So cosine squared theta would be that squared. And then divided by x, which is 5 divided by root 3 squared. You just simplify it from there. And now kind of regretting my spacing here. Sorry. Hopefully you didn't need that. Anyway, so let's simplify this. We'd have 3,000 times 1/4 over 25 over 9. Let's see. We could probably cancel between 3,000 and the 1/4, right? So like cancel a 2, you get 1,500. Cancel another 2, you get 750. So we have 750 times 9 over 25. And then the 25 and the 750 can cancel as well. So we'd end up with 30 times 9 or 270. So d theta dt at the moment that theta is 60 degrees, looks like it would be 270. All right, I haven't checked this, so you might want to check my arithmetic, but my procedure should be pretty dead on. So, and you can go back to this rule every time you're asked to find something, So like they asked for d theta dt. Oops, I just did 60 early. All right, let's do 30 now. There's no rule that says you had to do it in order. Anyway, so, what would that be? So you'd have 3,000, right? And so now you'd have a right triangle that looks like this. Remember, this is 5 still. This is 30 degrees, right? And so, again, different ways to figure this out. But you could figure out what x is by doing opposite over adjacent. So tangent of 30 degrees is opposite over adjacent. Tangent of 30 would be the sine divided by the cosine. Flip and multiply, you get 1 over root 3. You could multiply both sides by root 3 and then multiply both sides by x. So you'd end up with x is equal to 5 root 3. There we go. That's a way to go about that. Okay. And then let's see, what would cosine of 30 degrees be? Root 3 over 2. Okay, so we're just going to put these things in. So cosine of 30 is root 3 over 2. And then x, we just found it's 5 times square root 3. There we go. Simplify it, we get 3,000 times 3/4 all over whatever 25 times 3 is, 75. All right. Again, you can cancel with the 3,000 and the 4. You end up with 750. So you get 750 times 3 over 25 times 3. And your 3's cancel, and your 25 and 750 can cancel. I think you get 30. Okay. All right. Let's see. Okay, we'll come back and write a sentence when we're all done. Okay, let's go ahead and take care of the last one. That is when theta is 75. So at this point, this should be feeling pretty repetitive. And remember, we're just going back to this master related rates rule, or not really related rates, but that rule for d theta dt each time. So d theta dt, when theta is 75 degrees, would equal 3,000. Let's see, let's get a picture here. Pretty steep angle this time. 75 degrees, opposite over adjacent. Let's see. So this time I would probably go ahead and use a calculator for part of it. So, so for example, cosine of 75, I mean, I guess you could like really go for it and, bust out, think of 75 as what? 30 plus 45 and use the sum angle formula for it. But I'd probably just use a calculator. So I would just do cosine of 75 degrees. Make sure you're in degrees mode when you do that. Square the result. And then for the x value, I would do tangent of 75 degrees equals 5 over x. Solve for x by multiplying by x and divide by tangent of 75. And then, get a calculator, decimal for that. So anyway, and then whatever you get, that's what you would square down here. And then you get some fun number. I'll just say is approximately equal to something. So anyway, I don't have my calculator with me, so you'll have to trust you that you can do that. Anyway, so therefore, our conclusion would be that theta was the angle of elevation from the observer to the plane. Plane is, and that angle is increasing at a rate of, and then remember with angle measures, you're supposed to assume radians unless stated otherwise. But for this problem, it was stated otherwise. We were using degree measures this whole time. So let's see. So they asked for 31st, right? So we're going to say 30 degrees per, and what was the time increment? Hour. And then for 60, what did we get for 60? I should have underlined it. Oh, I did. Ha ha ha. Okay, and then 270 degrees per hour. And then I would personally would punch that into a calculator and get it, but if you're like me, you don't really have a calculator right now. I suppose I could have simplified this a little bit, but this is, I'm just going to say this value. Degrees per hour. When the angle elevation is 30 degrees, 60 degrees, and 75 degrees, respectively. There we go. All right, I hope this helps. Take care, everybody.